Now, in order to solve matrix questions, we're going to need the inverse, because we've already learned that if you have an inverse, you can multiply by that inverse, and that product that you get is the identity matrix. And the determinant appears in the inverse. So if you have a 2 by 2 matrix, the inverse is 1 over the determinant. So notice that you have the determinant here. Then these two values are just switching those ones over. And then you add a negative to the other diagonal. So if you go 1 divided by your determinant, switch those two on the diagonal and make the other diagonal negative, when you multiply that by A, you will always get the identity matrix. So there's 2. Get you to try. So you're going to find your determinant first. Over this here, I'll call this B. So this will be B inverse. So in our first one, the determinant is 1, so we go 1 over 1. Then we flip our main diagonal and make our other diagonal negative. For the second one, you can choose to have it either with the fraction out in front and keep it that way, or you could multiply that 1/3 through everything. I actually prefer keeping that fraction out in front, because if you have to do any other calculations along the way, then it's going to be nicer if that fraction's out in front, so you don't have to work with that fraction all the way through. For example, if you wanted to multiply B inverse by B, if I kept that 1/3 out in front, and then I wrote B, what am I going to get? Well, I'm going to take this first row and multiply it by the first column and then add. So I'm going to get 3 there. Then I'm going to multiply first row and second column. This is going to give me -2 plus 2, which is 0. Oops, I used that color already. Second row, first column is going to give me 0 as well. And finally, second row, second column is going to give me 3. Then if I multiply that by the 1/3, I still get my identity matrix, 1, 0, 0, 1. If I had that 1/3 in there to begin with, it would still all work out, but you'd have to work with those fractions when you did your mental math. And so this just allows you to do that fraction part at the end, which makes some of your calculations a little bit easier. So this is the reason before we said that a singular matrix doesn't have an inverse. And remember, a singular matrix is when the determinant is 0. Well, we need to divide by the determinant of the matrix to find its inverse. So if you have that determinant equaling 0, then that fraction out in front doesn't make sense, because you'd have 1 divided by 0. And so that's why a singular matrix has no inverse. Again, you can do inverses on your matrix as well. So we had that 3 by 3 in there. If I go and take my matrix A, which was my 3 by 3 before, and I do A inverse, it will give me my matrix inverse. Another nice thing to do is often, in this case, everything is in decimals. You can take that answer and change it to a fraction so that all of your answers are fractions. Oh, then you'd have to use your arrow keys over to see the rest.
Oh, okay.
So it's just using this -1 button, which is to get your inverse. If you do the inverse of your inverse, what should you get? What you started with. So here's one. We could type this into our calculator. Oh, that's not what I wanted to do. Oh, I erased more of it. Whoa. Something went bad. Okay. Well, I had it nicely behind something and then I erased. Oh, there it is. Awesome. So if you type that one into your calculator and then did the inverse, that is what you would get. So you can write that down if you want, but it's really not that important for your notes, just to know that you could type it into your calculator.